A moon should be simple, small, cold, dead. It should orbit its planet, reflect a little sunlight, and slowly freeze into silence. It shouldn't have weather. It shouldn't have movement. It shouldn't have anything that resembles a living environment. And it definitely shouldn't have an ocean. Because oceans belong on worlds with sunlight. Oceans need energy, warmth, continuity. Without constant input, cold winds. Ice spreads, liquid disappears. That's what should happen. But there is a moon in our own solar system that breaks this expectation completely. A moon covered in ice, hiding an ocean beneath it. Not a small ocean, a global ocean. An entire world of liquid water sealed under a thick frozen shell, locked in darkness, with no sunlight reaching the water below. If that sounds impossible, it's because it should be. A moon like this should have frozen solid a long time ago. Its internal heat should have faded. Its chemistry should have slowed to nothing. And yet, evidence suggests the ocean is still there. Active, which means something is keeping it warm. Something is constantly supplying energy in a place where energy shouldn't exist. And once you understand what that something is, you will realize why this moon might be more important than most planets we've ever studied. Because it suggests the universe doesn't need a sun to create a living environment. It only needs a heat engine, a source of energy that doesn't care about day and night, that doesn't care about distance from a star, that doesn't stop. And some moons have exactly that. A hidden ocean under ice is already disturbing. But the next detail is worse. This moon's surface may be cracking, opening, moving, which means the ocean below might not be completely sealed. It might be interacting with the surface. And if that's true, then this isn't just a frozen moon. It's a world with an interior environment that could be exchanging material with space itself. A world we can study without drilling through kilometers of ice. A world that might be giving us signals. Small ones. Rare ones. But real. In the next part, we're going to break down how a moon can hold an ocean without sunlight, and why the force keeping it alive is the same force that turns it into one of the strangest places in the solar system. The first mistake people make is assuming heat only comes from a sun. Sunlight is the most visible source of energy, but it's not the only one. A world can generate heat internally. It can trap heat from formation. It can produce heat from radioactive decay. It can warm itself through pressure and chemical reactions. But for small moons, that usually isn't enough. They cool quickly. Their interior should solidify, their geology should stop, and their oceans should freeze. So when scientists began to suspect that a frozen moon could still have liquid water, it created a serious problem, because it meant a new energy source had to be involved. And there is one source that can keep a world warm even in the deep cold. Tidal forces. This is the same force that creates ocean tides on Earth. But on some moons, it becomes something much more extreme. A moon orbits a massive planet. That planet's gravity pulls on the moon. But the pull isn't equal everywhere. The side facing the planet is pulled more strongly than the far side. That difference stretches the moon, and as the moon moves through its orbit, the stretching changes. Ober and ober, squeeze. Relax. Squeeze again, like bending a metal wire repeatedly until it heats up. That constant flexing generates internal friction. Friction becomes heat. And unlike sunlight, it doesn't stop. It continues as long as the orbit remains slightly imperfect. As long as the moon isn't in a perfectly circular orbit, tidal heating continues. This is how a moon can stay warm inside while being frozen outside. It becomes a heat engine, a world powered by gravity. Now add ice to that system. Ice forms a crust, kilometers thick, sealing the ocean below. That crust acts like insulation. It traps heat beneath it, which means liquid water can persist, protected from space, for an extremely long time. And that alone would be significant. But the evidence goes further. Scientists have observed surface features that suggest movement, cracks, ridges, patterns that resemble a shell being forced to shift and rearrange, almost as if the surface is responding to pressure from below. In some cases, there may even be signs of material erupting outward, Not like a volcano of lava, but a volcano of ice and water. If that's true, it means the ocean isn't just sitting there. It's interacting, which makes this moon different from a sealed, silent world. It becomes a system. Energy below, ice above, stress between them. A living mechanism. And mechanisms like this don't just hold water. They create chemistry, because if water is in contact with rock deep below, reactions happen. Minerals dissolve. Compounds form. Energy is released. On Earth, similar conditions feed entire ecosystems in the deep ocean, not powered by sunlight, but by chemistry. So when you combine tidal heating, a global ocean, and rock-water interaction, you get something that looks less like a frozen moon and more like a hidden environment that could support lifelike processes. Not guaranteed, not proven, but possible. And possibility is the dangerous part. If this moon really has a hidden ocean, the question changes immediately. It stops being, is there water, and becomes what is happening inside it. Because water alone isn't enough. What matters is energy, chemistry, time. And this moon may have all three. A warm interior powered by tidal squeezing, a global ocean protected under ice, and an environment that could remain stable for millions or billions of years. That is an unimaginable amount of time for chemistry to evolve, for complex reactions to develop, for systems to become organized. Even if life never appears, the environment itself becomes important, because it proves something we didn't want to accept. That habitable conditions might exist in the dark, not around stars, under ice, powered by gravity, which makes our traditional idea of the habitable zone feel almost naive. We imagined a narrow ring around a star where life could exist. But moons like this suggest a different truth. Habitability may not be about location. It may be about engines. Any world with a constant source of energy and liquid water could be a candidate. And in the solar system alone, there may be multiple worlds like this. Not planets, moons. Hidden oceans under ice, warmed by tidal forces, protected from radiation, isolated from the chaos of the surface. But here's where it becomes truly unsettling. If this moon has an ocean, it may not be the most active one, because there are moons where evidence suggests something even more direct. Plumes, jets of material erupting into space, water, ice, and compounds escaping from the interior and spraying outward. If that exists, it means we don't have to guess what's inside. We can sample it. We can analyze it. We can detect chemistry that shouldn't be there. And that brings us to the next exception. In the next video, we're going to look at a moon that may be leaking its hidden ocean into space right now. A moon that isn't just hiding an environment, but exposing it. And if the chemistry in those plumes is what some scientists suspect, then the question of life stops being distant. It becomes immediate, because it means the closest habitable environment to Earth might not be a planet at all. It might be a frozen moon that never sees a real sunrise, but refuses to be dead.